Okay, so today we're going to be working on 6.8, which is factoring trinomial squares and the difference of two squares. So as you look at your notes, you're going to see some rules up at the top that describe those trinomial squares. What we're going to do is find out, are some of these trinomials applicable for this trinomial square rule? So for example, if I have x squared plus 6x plus 9. Now we know if we're asked to factor that, we can break that apart to say, this is kind of like back in 6.6. What are my factors of 9? Think about that. 1 and 9, 3 and 3. Okay, so I know this will mean x, this will mean x. I can do my 3 and 3 because they multiply to give me 9 and they add to give me 6. So 3, 3, these are both positive, so it's going to be plus and plus. That gives me a real quick answer. So another way I can simplify this even further is x plus 3 squared. That totally works. What happens though if I get a much messier problem that's hard for me to think of the factors that multiply to get me to 9 and add to get me to 6? And what if my leading coefficient isn't 1, like we saw in 6.7 where there was a lot of guessing and checking? You can potentially use these factoring trinomial square rules to help you out. So let's play with one of those. Again, you can always go back to just factoring, but it may take you a while to get to a good answer. Minus 56x plus 49. So here's an example where this one's pretty messy. There's no greatest common factor that I can pull out, so I can't simplify this any further. So I've just got to factor this thing. As I do that, I might be doing a lot of guessing and checking to see what's going to go into my two binomials down here. Or I can use the idea of those trinomial square rules. So in order to do that, I want to think about this as being a squared, and then I've got minus 2ab plus b squared. Okay, so this is my a squared. This is when I'm combining and playing with my a and my b. Kind of makes sense as I was multiplying those guys together. And this is my b squared. Using this as a guide for each of these terms, let's see if these three rules or these three standards play out. And if they do, then boom, I can quickly give us an answer here. So the first question is my a squared and my b squared, are they squares? So basically, can I square root this? Yeah, it would be. So my a would be 4x. If I were to square root, 4 times 4 gives me 16, and x times x gives me x. So yeah, that is a square of something. I can square root it. And how about my b over there, this b squared? Could I square root 49? Yeah, I would end up with 7. So in my little thought bubble, yeah, because my a would be 4x. 4x squared gives me that. And my b would be 7, and 7 squared, yeah, it gives me that. Okay, so that checks off. So I can say yes. The second test to see if it's a trinomial square, and if I can use this trick or this rule to help me out, is my a squared and my b squared must be positive. So are they both positive? Well, yes, positive, and yes, positive. I can also look back at my a's and my b's. Are they positive? Yes and yes. So we're doing good. There's only one more question I have to ask myself. So when I multiply 2 times my a times my b, do I get this middle term? So let's see. If I do 2 times my a times my b, am I going to end up with that? So let's see. 2 times 4x would give me 8x. 8x times 7 gives me that 56x. Looking good. So because I can say yes, yes, and a yes, I know that my a is going to be 4x, and my b's are going to be 7. And looking at the rules at the top of your page, because I have a minus here, I know I'm going to end up having minuses for both of these guys. So again, this is where learning a formula, learning a rule will help you potentially save a lot of guessing and checking to figure this out. And now if I want to simplify this even further, I could say this is 4x minus 7 squared. And again, I've saved myself all the guessing and checking because I went through 3 steps. Are they both squares? Are they both positive? And when I multiply a times b times 2, do I get this middle term? If you get a yes on that, then you're good to go, and you can use the rule at the top of the page. One other thing I want to show you is the difference of 2 squares. And in your notes, you had a lot of examples of that trinomial square, so play with those. As you play with them more, you'll get more comfortable with using those 3 criteria. All right, so the difference of 2 squares. And the rule for this one says a squared minus b squared is going to equal a plus b times a minus b. So let's see what that might look like. If I have x squared minus 9, so I got to ask myself, can I square root this guy? Can I square root this guy? And I'm going to subtract them. Is this the difference, remember difference means the answer when you subtract, of 2 squares? And if it is, then my answer is easy. I'm going to have x, because the square root of this one, and an x, and I'm going to have a 3 and a 3, and I need 1 positive and 1 negative, and there's my answer. I don't have to do any math. I just know that rule and can apply that rule and get my solution. Let's try another one. X squared minus 4. So if I were asked to factor that, I'm going to think, so can I square root this guy? Yep. Can I square root this guy? Yep. And am I subtracting? Yep. So that's the difference of 2 squares. So now my answer is going to be square root of the first one, square root of the second one, 1 positive, 1 negative. If you want to check yourself, you can absolutely box this out and see what you get. X 2, x negative 2. So I end up with x squared. Here's a negative 2x. Here's a positive 2x. And here's a negative 4. When I combine these guys, notice I've got my x squared, 2x minus 2x. Those guys are going to cancel out. So just minus 4. So I do get back to my original question. Kind of cool? Here's an example. Can I use difference of 2 squares for this? And your answer should be no. Because as you think about it, can I square root this guy? Yep. Can I square root this guy? Yep. Is it the difference of 2 squares, though? It's not. So I can't factor this one. I can't factor it. It's not factorable. Can't be factored. Okay? So it has to be the difference of the 2 squares. And then I can take the square root of each, and one's plus, one's minus, as you set up those 2 binomials. All right, good luck.